In the last video, we discussed about the addition, subtraction, multiplication, and division of scientific notation and also significant figures. Okay, so scientific notation means the number which is represented in the form n into 10 raised to plus or minus n. It may be minus value or plus value. Okay, what is the capital N value means? It must be greater than 1, less than 9, less than 10. Okay, not 9, greater than 1, like 1.1, 1.2 are exactly equal to 1. Okay, less than 10. Understand? So this is okay, scientific notation. What are significant figures means? The numbers which we are going to consider for our respective value. Precision is there, accuracy is there. With respect to that, we have some significant figures. Significant figure means which are very important. Okay. So in the significant figures means the basic thing, all non-zero digits. Except 0, all the digits are significant figures. Okay. So 0 in between two non-zero are the significant, like 1000, 1. So significant figure is 4, like this. 1001 is there. So these zeros are in between non-zero digits. So of course they are significant. Okay, but 1000, it has a significant figure 1. If point is there, then the significant figure 4. Understand? Without point, this 1000 means the significant figure is only 1 because this can be written in 1 into 10 power 3 form. Okay, if decimal point is there, then the significant figures are 4. Okay, so the decimal points after the zeros after the non-zero digit before the decimal point are significant. Okay, if 0.00001 is there, significant figure is only 1 because these zeros represent the position of the decimal point position. Okay, so these are all significant figures. And how to round up, you know, if the last digit is less than 5, then the preceding term is written as it is. If the last term is greater than 5, then the preceding term is added by plus 1 and increased by plus 1. Okay, if the preceding term exactly equal to 5, then the last term is exactly equal to 5. We have to check preceding term. Whether it is even, it should be written as it is. Whether it is odd, then it is increased by plus 1 unit. Okay, those are the rules. Next one is laws of chemical combination. Laws of chemical combination. Okay, so in that, students, total 5 laws are there. In that first one, law of conservation of mass. Second, law of definite proportion. Okay, third one is law of multiple proportion. Next, you already learned what is Gay-Lussac's law. In states of matter, you already learned Gay-Lussac's law. And last one is Avogadro's law. So these are the 5 laws which tells about the chemical combinations of the matter. How the combination takes place, what are the rules, how the chemical reactions happen. Understood? So students, so these are the 5 laws which tells about the chemical reactions, how the masses varies, how they combine, at what ratio they combine, if they combine, before combine what is their proportion, after combine what is their proportion. Okay, so that is our experiment. And this Gay-Lussac's law and Avogadro's law is purely for gaseous atoms. If the gaseous atoms combine together, these are for all liquid, metal, gas, solid, liquid, gas, and these two are specially for gases. Gay-Lussac's law as well as Avogadro's law. Understand? Okay. So in that we will discuss one by one. Listen, first I'll explain law of conservation of mass. You know already law of conservation of energy. What it means? The energy neither be created nor be destroyed, but it can be converted from one form to another. Similarly here also. Here we are considering what? Conservation of mass. That means mass can neither be created nor be destroyed. But in the chemical reaction, the mass of the reactant is combined together to form a product. Okay, only the chemical behavior change, but the mass remains same. Understand? So in a chemical reaction, mass can neither be created nor be destroyed. Okay, next, law of definite proportion. For example, if take any one compound, H2O is there, CO2 is there, CaCO3 is there, whatever compound you take, whether it is derived from decomposition reaction, combination reaction, or precipitation reaction, we won't bother about it. Okay, even though it is derived from so many reactions, but their combination is always same. If CO2 liberated from photosynthesis, that is also consists of one carbon atom, two oxygen atom, CO2. If the CO2 is released from respiration, that is also consists of one carbon, two oxygen, CO2. Okay, if CO2 is liberated from automobiles, okay, vehicles, that is also consists of C plus O2 CO2. If CO2 is released by burning wood, that is, those processes are different, but the combination of CO2 is same. That is what? Definite proportion. The compound, we don't bother about from where it is derived. If it is derived from either combination, decomposition, combustion, okay, or any biological process, even though the combination remains same. Like CO2. H2O means whether it is derived from, if ice is converted into water, that is H2O. If any hydroxides undergoes decomposition forms H2O. Understand? In photosynthesis they form H2O. Understood? So those are all what? The H2O means in all the manner it consists of two molecules of H2, one molecule of oxygen. Okay. Next, law of multiple proportion. Multiple proportion means, for example, I'll take example of H2O and H2O2. One is, okay, this one you take carbon monoxide and carbon dioxide. Okay, both are carbon, both are oxygen. In CO and CO2, only carbon and oxygen is there. But CO is different, CO2 is different. Here, the proportion of C is constant. That is definite proportion. What is multiple proportion means? In any compound, the composition of one compound kept constant, which is combined with different proportion of another compound. Here 1 mole, here 2 mole. Understood? This is multiple proportion. Same compounds combined in a different proportion to form different products. If our carbon combines with 1 mole of oxygen, it forms carbon dioxide, carbon monoxide. If carbon combines with 1 mole of oxygen molecule, then it is CO2. Similarly, H2O and H2O2. Both are example. Here, hydrogen H2 combines with one atom of oxygen from H2. Here H2 combined with one molecule of oxygen from O2. H2O2. Understood? Atoms are same, both are hydrogen and oxygen. But the hydrogen composition is same. One kept constant, another one will vary. That is called law of multiple proportion. Okay. Next, Taylor-Sykes law means if any gases combine together, okay, they always obey a simple whole number ratio. Understand? They cannot be in fraction form. They always obey a simple whole number ratio. For example, C plus O2 is there, isn't CO2. Here 1:1 ratio. Correct? So H2 plus O2 is there, that is H2O. To balance this, you have to. So this is 2 moles, this is 1 mole. This is 2:1 ratio. We cannot take this as, here 2 is there, we can take this as half. 1:1 by half, 1 by 2. That is not possible. They are not present in the form of a fraction. Okay, they cannot be in the form of a fraction. They are always in a simple whole number ratio. Understood? That means this half is wrong. Always, always the balanced reaction is correct because they give us a simple whole number ratio. That is the correct reason. 2:1 is the answer. That's what explained by Gay-Lussac's law. And Avogadro's law means, of course, it directly tells about the number of atoms present in 1 mole of a substance. If any gas is there, individual gas, along H2 is there, 1 mole, it also consists of 6.023 into 10 power 23 atoms. If alone O2 is there, it is also consists of 6.0, means Avogadro number of atoms. If combined together, water vapor is there, H2O. Okay, H2O also present in the form in the number is equal to Avogadro number. Whether it is an atom, molecule, ion or a compound. If it is 1 mole, that is always equal to Avogadro's number. Understood? So we will discuss one by one with the example. So first one is law of conservation of mass. So these all laws are very important for 2 marks students. All the 5 laws are important for 2 marks as the exam orientation. Their statement and one example. Okay. So this law of conservation of mass is explained by Antony Lavoisier in the year 1789. This law of conservation of mass was proposed by Antony Lavoisier in the year 1789. What is the statement of this law? Listen. In a chemical reaction, because we are studying chemical class in chemical combination. In a chemical reaction, mass can neither be created nor be destroyed. This is law of conservation of mass. Mass can neither be created nor be destroyed. In what? In a chemical reaction. I'll take one example. Here listen. I'll take this one only. H2 plus O2, that is 2 moles, gives rise to 2H2. Okay? Students here, 2H2. Okay, 1 hydrogen atomic mass is 1. Here 2 2s are 4 hydrogen is there. So atomic mass is 4 gram. Plus oxygen molecule. 1 oxygen is 16 gram. Atomic mass of oxygen is 16. Here O2 is there. That means 32 gram. Okay, if you add both, you will get 36 gram. Okay, here 2 into is there. Hydrogen is 2 plus this one is 16. Oxygen only 1 mole is there, that is 16. Hydrogen 2 is there, 2. That 2 moles are there. So 2 into 18 is 36. So in the reactant side, mass is same. In the product side, mass is same. That means it satisfies the law of conservation of mass. Law of conservation of mass satisfied, obeyed, proved. Understood? So here what happens? H2 is different alone. It is a gas. It is a gas. It is a liquid. H2 alone has a different. O2 alone has a different character. H2 has its own character. The character of the reactant species and the product species changes, but their masses remain same. That's what law of conservation of mass. This is a combination reaction. And take another one, that is decomposition reaction. CaCO3 decomposes to give CaO and CO2. So students, the calcium atomic mass is 40. And right here, you calculate yourself. Calcium atomic mass is 40, carbon atomic mass is 12, oxygen atomic mass is 16. Oxygen is 3 times. Okay, you just calculate this, you will get 100 gram. 40 plus 12 plus 48. You will get 100 gram. CaCO3. Here, calcium is 40, oxygen is 16. That is 56. This one is 44. If you add both, you will get 100. So reactant side is also 100, product side is also 100. Okay, the mass is conserved. Okay, here the CaCO3 is, it is a salt. Here CaO is an oxide. CO2 is a gas. You know, their nature changes, behavior, the chemical property changes, but their mass is conserved. That is what a law of conservation of mass. Not only these two examples, if any reactions occur, if we balance them, that always gives us a law that always obeys the law of conservation of mass. Whatever the mass is we are using in the reactant side, that much of mass is produced in the product side. If it is not possible, listen, if H2 is there, O2 is there. Assume it forms only H2O. H2 is there, O2 is there. Alone it forms only H2O, 1 mole of H2O. Among these two, any one is a limiting reagent. Later I will explain what is limiting reagent. So just now you understand what is law of conservation of mass. Understood? Okay. This one. Mass can neither be created nor be destroyed. And these are the examples. This is example 1 you take. Example 2 you take. I am not telling only this example only you have to give. You may select any. Okay. Carbon plus oxygen gives rise to CO. Listen here. Example 3 I will write. C plus O2 gives rise to CO. Okay. Here to balance that we require this. Here 2 oxygen is there, we have to write here 2. 2 carbon is there, that's why we balanced this carbon with multiplying with 2. Okay, so students, carbon is here in 2 moles means it is 24 gram. 12 2s are. Atomic mass of carbon is 12. You need not to calculate what? Atomic number. You have to consider atomic mass because we are studying conservation of mass. Okay, next this one is 30. Alone 2 into 12 plus 16. Okay, if you add you will get 56. Okay, here 2 into 28 that is 56. Correct? No matter which reaction it is, always this satisfies law of conservation of mass. Okay? Next, you may write it for, I'll give some example to you students. This is for HWO. NaOH plus HCl gives rise to NaCl plus H2O. You calculate yourself, okay? NaOH plus HCl gives rise to NaCl plus H2O. Next. MgOH twice. Decomposition gives rise to MgO plus H2. Try those two. Okay, that is for equipolyester. is second one. Law definite proportion. Okay, so students, this law of definite proportion is proposed by Joseph Proust. Joseph Proust, okay, is a French chemist. Okay, here not yet mentioned. So law of definite proportion is proposed by Joseph Proust, a French chemist. Okay, so students, here what is this law of definite proportion tells us? This is a negative statement. A given compound always always contains exactly same proportion of elements. Exactly same proportion of elements by weight. Remember, that is by weight. So a given compound always contains exactly same proportion of elements by weight. I'll take two examples here. So first one is formation of CO2 consists. C plus O2 gives rise to CO2. Okay. Next, C6H12O6. Okay. This undergoes what? Photosynthesis by using sunlight. Photosynthesis. Okay. They form 6 moles of H2O plus 6 moles of CO2. In presence of oxygen. Photosynthesis. How many moles? 3 moles. Okay, 6 moles of H2O and 6 moles of CO2. Next, another one you consume CaCO3, not CaCO3, MgCO3. MgCO3 upon decomposition gives MgO plus C. All are gases. From here only CO2 is liberated, CO2 is liberated, CO2. So this is a combination reaction, this is photosynthesis, this is a combustion reaction. Combustion is burning in presence of air. Okay, that is combustion reaction. And this one is decomposition reaction. Okay, so no matter students whether it is formed from combustion or any photosynthesis or any decomposition reaction or a combination reaction, always here I am considering in the common term is CO2 is there. Okay, a given compound that is CO2 always contains exactly same proportion. Here also CO2, CO2, CO2. We don't bother about 1 mole, 6 mole, 1 mole. We consider CO2 only. Then that CO2 is always contains exactly same proportion of elements by weight. That means if here you calculate, it is 44 gram. Here also calculate, it is 44 gram. Here also calculate, it is 44 gram. No matter from which reaction it is derived, always a particular compound, if CO2 is there, always its atomic mass is 44 only. Molecular mass. If H2O is there, always its molecular mass is 18 only. If CaCO3 is there, okay, assume CaCO3 is there, always its molecular mass is 100 only. Whether it is derived from any reactions, we don't bother about that. A given compound, a particular compound, it always consists of exactly same number or same proportion of elements by weight. Always CO2 means it is 44 gram only. Similarly, here, mg is 12, this is 16. Okay, 12 plus 16 means 28. Always, this MgO is prepared from any other reactions by combination, by decomposition. Listen, this is MgCO. You consider MgOH twice. Upon decomposition gives MgO plus H2O. Okay, students, Mg derived from this or this, we don't bother about that. Always the composition of Mg is how much? 28 only. That is what law of definite proportion. A given compound always consists of equal proportion of elements by weight. Understood? Okay. This statement and any one example is enough. Okay. Next one. And also remember whether this is a naturally occurring element or a synthetically prepared. For example, CO2 we can generate it in the laboratory also. If any carbonate salts is treated with acid, okay, any carbonate salts, if they are treated with acid, CO2 gas is prepared. You know that in the 10th standard you have one what is that carbonate test, lime water test. If CO2 is prepared, zinc chloride test you are checking now. Zinc is there, zinc granules are there. To that you are adding HCl. In that H2 gas is liberated. By bubble you are going to observe whether the gas is liberated or not. Similarly, for whether CO2 is released or not, to know that if any carbonate, whether it is sodium carbonate, sodium bicarbonate, anything, okay, washing soda or baking soda. To that, if you add any acid, they form gases. That is the H2O gas. That gas is the term here. It is a test tube, you assume. It is closed. Here the salt and the gas is there. This is dipped in lime water. That is CaOH twice. Lime water solution. Okay. So the gas evolved here is a CO2 gas. If it is combined with this CaOH twice, isn't it what happens? CaOH twice plus CO2 gives rise to CaCO3 plus H2O. They form white precipitate. Lime water turns milky. You know that. You already did, I think so. In 10th, it is there. Okay? Test for carbonate ion. Okay? In that, if you do this is a lime water. If CO2 is released, then it turns milky color, white color. That is the formation of CaCO3. Understand? So that is what sorry, we can, this is what laboratory we synthesize that. Understand? In respiration, that is a natural process. In that we release CO2 gas. So whether it is a naturally occurring element or a synthetically prepared, then also their composition is same. CO2. From respiration, what we exhale the gas that consists of water vapor and CO2 also. That CO2 also consists of 44 gram. Okay, it is also 44 gram by weight. Here we prepared this in laboratory. CO2 liberated here is in laboratory. It is not a natural process. Then also its composition is 44 gram by weight only. Understand? Whether it is synthetic, natural, then also they consist of equal, exactly same proportion of the elements by weight. Next one is law of multiple proportion. Third one is law of multiple proportion. So students, this is explained by scientist John Dalton. Right, completely. John Dalton in the year 1808. here 3. Okay. Okay. So what it states, if two elements combine together to form two different compounds, okay, then not two different, more than one you take. More than one compounds. Okay. Then the masses of one element is fixed. The masses of one element is fixed. The masses of one element is combined with the fixed mass of other element. This is the statement. Okay, what it is, students? If two elements combine together to form more than one compound, okay, more than one, not exactly true, I'm telling more than one compound, then the masses of one element is combined with fixed mass of other element. That means what? If two elements are there, A and B, the element A is kept constant, element B combines with A in a different proportion. That is what? One element is combined with fixed mass of other element. That means among two elements, any one element has a fixed mass. Understand? So, I'll take the example here. Example is H2O and H2O2. You can easily understand. So students, here, if H2 is there, if it combines with half O2, gives rise to H2O. This cannot be in proportion. Just listen. Okay? Next. If H2 is there, combines with O2, it forms H2O2. Okay? I'll take the same reaction here. If we balance this become 2H2 plus O2 gives rise to 2H2O, and this one H2 plus O2 gives rise to oxygen. Here this is fixed and this is different. Understand? No matter which is kept constant, which is fixed in proportion, which is variable. But if one element mass is fixed, another element mass is variable, then it is called as law of multiple proportion. Here both hydrogen and oxygen, the nature is same. But H2O is different, H2O2 is different. Correct? It is a water, it is an acid. Peroxide, oxide it is. Understand? Okay. Similarly, another one example is there, like that. CO and CO2. And right here, listen. Here, C plus O2, that is half moles, gives rise to CO. Next, C plus O2 gives rise to CO. Correct? Next. Similarly, you take that here. If you balance the students, it will become 2C plus O2 gives rise to 2CO, and C plus O2 gives rise to CO. Here also, in this, the definite proportion is explained by carbon. Here both are carbon and oxygen. They combine with each other in a different manner, but the carbon proportion is fixed, oxygen proportion is varied. The one element reacts with or combines with fixed proportion of other element to form a different carbon. You know, CO is different, CO2 is different. Correct? Here. Okay. So here it is half mole, here it is 1 mole, here it is 1 mole, here it is 1 mole. Understand students? Okay, these combine with each other to form CO and CO. Both are different. The nature is different. But carbon is same, oxygen is same. Being based on their different proportion value, they form a different compound. Here with respect to carbon, it is fixed proportion. With respect to oxygen, it is a multiple proportion. Here you consider. This one is 2 mole. This one is 1 mole. This one is 1 mole. This is also 1 mole. So students, in this, the oxygen proportion is kept constant. The variable constant proportion is carbon. Means, so this carbon, oxygen combine with each other in a different proportion to form these compounds. Understand? Here, this is a fixed proportion. This is a multiple proportion. So any one element combined with other element to form different compounds. Understand? So the next one is Gay-Lussac's law. Okay, fourth one, that is Gay-Lussac's law. Okay, so this law is purely, of course, the scientist Gay-Lussac proposed this law. That's why the law is Gay-Lussac's law. Okay, so students, this is purely explains about volume of gases. Okay, this law is purely explains about what? Volume of gases. Okay, next one. What is the statement? If the gases combined or reduced, if the gases combined or reduced, they do so in a simple whole number ratio at simple whole number ratio at same temperature and pressure. This is the statement of Gay-Lussac's law. If the gases combined are produced, they do so in a simple whole number ratio at same temperature and pressure. I take example for combination and liberation both. So listen, H2 is a gas combined with O2, that is oxygen, to form H2O. Don't bother about this whether it is a gas, liquid. I'm telling only combination of gases or production of gases. If we balance, it is like this. So students, if it is 2 means it is 1 mole means the ratio is 2:1. 2:1 is a simple whole number. Okay, listen. If we take this in 100 ml, combines with 50 ml of oxygen, 50 ml of 100 ml of H2 because 2 moles we require. Combine with 50 ml of O2, gives rise to 100 ml of H2O. Assume. Okay, so 100 is to 50. If you divide this, it is always 2 is to 1. Okay, so if any gases combine with each other in a chemical reaction are produced, this is example for combination, produce later as. So they always do a simple whole number ratio. Understand? For decomposition reaction, assume NH3 decomposes to N2 and H2. To balance this is. So students here, this N2 and H2 are in the ratio 1:3. Okay, consider if (200 ml of this is 200 ml of NH3 decomposes to give 50 ml of nitrogen and 150 ml of hydrogen. If you divide 50 is to 150, that is 1 is to 3. Whether the gases combined or produced, they always do so in a simple whole number ratio. No matter whether they given in gram, whether they given in this ml, okay, or any other. They always do so in a what? Always present in a simple whole number ratio. That is explained by what? Gay-Lussac's law. It is purely a gaseous law. Okay. Next, the last one is Avogadro's law. Okay. All laws are important for 2 marks, as I told you. One statement and one example. So Avogadro's law I already told you, students. Why I am not taking much time to explain Gay-Lussac's and Avogadro's? Because in states of matter I already explained it. So the last one is Avogadro's law. Why it is called as like this means? Because this law is proposed by the scientist Avogadro. Okay, what is the statement of this law means? Listen. The equal volume of gases always consists of equal number of atoms. Okay, equal volume of gases always consists of equal number of atoms. That is Avogadro number. Okay, at same temperature and pressure. This is the statement. What is the Avogadro number? Listen, Avogadro number is represented by Na, that is equal to 6.023 into 10 power 23 atoms or molecules. Atoms are molecules. Understand? The equal volume of gases always consists of equal number of atoms at same temperature and pressure. The value is this much. I take example, listen. H2 is there, 1 mole. So listen, 2 moles of H2 combines with O2 gives rise to H2O. Assume, here H2 is there. Here H2 is there. Here oxygen is there. Gives rise to H2O. Because I individually write 1 mole, 2 mole. 1 mole. 1 mole plus 1 mole, 2 mole. So students, 1 mole of whether hydrogen, oxygen or water individually. no matter whether it is an atom, compound, ion. Okay, so always this is also consists of Avogadro number. This is also consists of Avogadro number. This is also consists of Avogadro number of atom. This is also individually consists of an Avogadro number. One more, one more, one more, one more. So one mole of oxygen, hydrogen, water. We don't bother about that, whether it is a gas or a liquid or any compound or an individual atom or a diatomic atom. Always the equal volume of a gas is 1 mole. Okay, consists of equal number of atoms. Understand? That atoms is equal to how much? 6.023 into 10 power 23. That is called Avogadro number. This is the statement. Any one example is enough. So they won't ask any example students. Always they'll ask, state Avogadro's law. Give the value of Avogadro number. This is important. Understand? So this is all about the 5 laws of chemical combination, which are very important for 2 marks. Okay? Thank you.